Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a typical multiple choice question number 18, refer to the topic 15, energetics in the high level syllabus. In terms of asking for definitions, right? In terms of topic 5 and 15, energetics, or we can say the chemical energies, this chapter requires students to memorize or recognize a lot of the definitions, right? Because a lot of the thermochemical equations are going to be given to you and not further explaining what is going on behind, right? So that's why remember all the definitions required. So this is one of them. They're asking which equation, so going to be a given situation, represents the lattice enthalpy. Remember, lattice enthalpy, a very important number that's showing how strong an ionic bond is. So developing to the concept, the strength of the ionic bond is shown by the number, whether large or small, about the lattice enthalpy. In this case, magnesium sulfide. So mind you that what is meant by lattice enthalpy is going to be here, the energy required. The first thing that you need to mention is going to be an endothermic situation. So energy is required. Energy required to break, right? Break a bond, right? So as a breaking bond is an endothermic process. Breaking, remember, energy required to break 1 mole. This is one of the really important criteria for all definitions in terms of delta H's, because for delta H, the unit is going to be something joules or something kilojoules per mole. Per mole means something must be in 1 mole. So remind you that for all definitions, something is going to be 1 mole and you must be pointing this out. So in the case of lattice enthalpy, the 1 mole is going to be 1 mole of solid ionic bond. So that means what we are now using the energy is used to break 1 mole of solid ionic bond back into gaseous state ion. Yeah, so this is the definition behind the lattice enthalpy. Energy required to break 1 mole of solid ionic compound, ionic bond, back into the gaseous state ions, right? So in this case, we must be starting 1 mole of solid ionic compound. So that's why, as you can see, or with the solid form ionic compound. So okay, but back into only gaseous state ion. So gaseous state, which means the part D is going to be wrong and it must be in the ion form. So that's why what we can sort out now is going to be B or C, right? But whether B or C is going to be true depends on our understanding in terms of the charges of the ions, right? As you can see, magnesium is going to be a group 2 element and sulfur group 16. So that's why, commonly speaking, when they are going to form ions, magnesium forms a +2 charge and sulfur forms a -2 charge, right? So that's a 2 plus and 2 negative will be the better choice for the charges representing the ions after the breaking of the ionic bond, right? So that's why answer is going to be C.